Good morning, everyone. My name is Vitaly. I come from SberAuto. I work for the department that is responsible for the app security and the security of the products of our company. And I'd like to talk to you about the Semgrep, which is a well-known tool, but I will focus on these technologies of SberAuto. This is our stack, cloud native microservices, backend, front React, and mobile React Native. And I'd like to draw attention to the fact that we are part of the bug bounty platform, so please take part in the bug bounty program that we run. As for now, Semgrep offers various solutions for dependency identification. I'll be talking about SAST, which is an open source version jointly with the community rules, as well as Semgrep code, which is our proprietary version, and it features an expanded set of rules, as well as the engine, which offers cross-functional and cross-procedural analysis. You can test Semgrep free of charge, and you will find additional details on the Semgrep website. Before that, we used various open source tools for different languages, and it resulted in the fact that we needed much time to update the rules, investigate the defects, and the lack of taint analysis was another drawback. Therefore, we started looking for a tool that would help us solve these problems. For the sake of comparison, I decided to use three tools that can do this analysis. The Go card, unlike the other two solutions, can only use Go for scanning the products. Semgrep and CodeQL support multiple languages. I downloaded it from GitHub for the typical dependencies, and I used the rules already built into these tools. Pluses in the table show when the rules did not work in the taint mode, or the mode was not part of the set of rules. However, it used a rule that identified a certain construction in a code. Overall, this is an advantage because by using these rules, you can fine-tune them for specific apps so they can run in the taint mode. I just want to mention that in the code there is a line that uses a parameter in the SQL request. It could be a true positive or a false positive depending on the source of the parameter. If it's a constant that was used somewhere in the code, then it's a false positive. If this parameter is taken from the request of the user, then potentially it could be with a high likelihood a true positive. There could be other nuances such as sanitizers, but anyway, that reduces the probability of a false positive significantly. After being run, Semgrep builds the AST tree, which is transformed into an intermediate language that follows the rules, and that allows us to write the same rules for different languages. In other words, the syntax is going to be the same, and as patterns, we use the construction of the source code. CodeQL requires the initial database of the project, and by running the tool separately, we create a database out of the source code. And the next round will identify the vulnerabilities with the help of the set of rules. The project scan and analysis require more time, but the more complicated syntax of the rules is the main disadvantage. So it will take more time to analyze the syntaxes and adapt your project. Semgrep offers ready set of rules. It doesn't require the project build, and Semgrep also supports the taint analysis, which allows you to track not just certain patterns in the code, like unsecure request, but it can also populate the request with the right data, and that reduces the number of false positives. It can be customized, and it supports the config file scan. This is important because the app security much depends on the configuration settings.
Рассмотрим режимы работы Semgrep.
Let's go into the Semgrep mode of operation. This is the SSRF attack. A server sends a request to an address provided by an attacker. Shown on the right-hand side is the Semgrep rule. Shown on the left-hand side is the code, and the code lines are highlighted, the relevant ones.
Также можно убрать из скана определенные директории.
You can also remove certain directories from the scan that will reduce the number of false positives and will reduce the scanning time. In the taint mode, not only do we discover the unsecure request, but we also identify the source of the data. And as a source, you can specify the function argument, which is relevant for the open source version, which can only run the taint mode within one function. And it could be useful for the joint mode that I will talk about later. As for the proprietary engine, it can done cross-functional and cross-file analysis. And this particular example shows that the source is not the function argument, but rather the request coming from the user. As you can see in the slide, the source and sink are in different functions, but if you run the Pro engine, the rule will still run, and you will identify the non-secure request. The disadvantage of the Semgrep comes into play here. Let's say we don't
И правило уже не отработает, не поможет даже.
We don't see the rule activated. The Pro engine is not going to help you here, and one of the solutions would be to use the join mode of Semgrep. It's similar to the join SQL request when you merge the tables by columns. Instead of the columns, we use rules, and instead of columns, we use meta variables. The previous case is split into two parts. You identify two rules that are then merged with the help of the join mode, and the resulting rule identifies the unsafe request.
Также стоит отметить, что для данного примера
It's worth mentioning that the open source version is sufficient for this particular case, and the proprietary engine is not a must. Another example when Semgrep is not going to work is when we get data not from the function argument, but from a pre-built structure. The rule is not going to be activated. One of the options would be to track the data coming into the structure when it is built. In other words, if this data is not coming from the config but from the user request, it might potentially cause problems. However, it's worth mentioning that this approach might result in increasing the number of false positives. Semgrep supports config files scans, and in this particular case, it identified unsafe configuration in the Android manifest file. And an Android app would be run in the safe mode, which poses security threats. In this particular case, the Semgrep identified a Docker file configuration, and it had the root rights, which is an unsafe practice. The proprietary version of Semgrep has templates to be integrated in various CI/CD systems, and you have to log into the Semgrep cloud for such an interaction. And following that, the Semgrep CI command is run. The rules and the settings are downloaded from the cloud. You scan locally, and the results are sent into the cloud. You can use the web interface to rectify defects, in other words, to do triage. Various utilities can run argument settings, and there is a Semgrep image that you can download and run. You can build your own images.
Поверх него собираем образ с набором актуальных правил.
You can build on top an image with the relevant rules. You can store it in the repository. A container is run on the GitHub runner, and the results are sent into the aggregator. If you want to update the rules or add new rules, all you need to do is revise the second image. In conclusion, I'd like to mention the languages supported by Semgrep. There are quite a number of them, and these are the links to the sets of rules. That brings me to the end of my presentation. I hope that you will find my presentation useful, and I'll be happy to take questions. I'll be happy to share my experience in using this tool. My contact information is shown in the slide. Please email to me your questions, and thank you so much for your attention.